We're going to be looking at fractions and decimals, and the first thing we have to look at with fractions is how to reduce a fraction. A fraction is in reduced form when the numerator and denominator have no common factors. And a common factor is simply a number that can be divided into both of the numerator and the denominator. So the example I used here was 10 over 6, which is not in reduced form because 10 and 6 can both be divided by 2. So to reduce, you would simply divide 10 by 2 and 6 by 2, and you would end up with 5/3. It's very important to remember when you're working with your online work in MyStatLab, if you're giving the answer in fraction form, which a lot of times they'll ask for a fraction form, and you do not reduce it, it will be counted wrong. So always be sure and check your fraction to see if it can be reduced before you enter your answer. There's a couple of different ways to reduce fractions. One is if you're looking at the fractions and you just automatically recognize a number that will go into both the numerator and denominator. If you're really good with your multiplication table, sometimes that's easy to do. It's sometimes harder to do when you have larger numbers because you may think of a number that goes into both of them, but it may not be the largest and you have to keep reducing. I'm going to show you how to do this the same way that is shown in your help me solve this and show me an example in your online work, so that if you need help solving a problem, I've shown you a similar method to what they're showing you. So we'll start with the 121 over 55. And the way they do this, the way they show you the examples is to break 121 down into its factors. So if you think of 121 and you try to think of something that will go into it, we know that 11 times 11 will go into it. So we're going to put 11 times 11, which is 121. And we call this the prime factorization of 121 because 11 can't be broken down any further. Now we're going to do the same thing with 55. And so you try to think of something that will go into 55, which would be 5. And 5 times 11 is 55. This would also be the prime factorization because 5 and 11, neither one can be broken further down. And the way we reduce is that we take out the common factor. So you see that we have 11 in the numerator and 11 in the denominator. And when we take that out, what is left is 11 over 5, and that would be the reduced form. So now you see the two different ways. If you look back up at the example I have explaining what reducing is, you see that you can just divide by a common factor. And then this method shows you how you can break it down, and then you see the common factor to divide out. So either method is fine. It's whichever method that's easier for you. The 275 over 220 is going to be a little more difficult to just think of the greatest factor to divide out. So this one is a good one to break down into its factors. So I'm going to go below here, and I'm going to just start with what's something that goes into 275. Anytime a number ends in 5, it can be divided by 5. So I'm going to divide by 5, and you can use your calculator to divide. 5 goes into 275 55 times. And then I'm going to see if that can be broken further down. 5 can't be broken down any further, but 55 can be rewritten as 5 times 11. So we would call that the prime factorization of 275. So I'm going to rewrite 275 as 5 times 5 times 11. And then we're going to do the same thing with 220. So I'm going to start with something I know will go into 220. It ends in a 0, so I know it can either be divided by 5 or 10. So I'm just going to go with 10 because it's easy to divide by 10. 10 times 22 would be 220. 10 can be broken down further into 2 times 5, and 22 can be broken down further into 2 times 11. So the prime factorization of 220 is 2 times 2 times 5 times 11. And it really does not matter what order you write these in. And what we're looking for is a common factor in the numerator and denominator. We see that they both have a 5, so that would divide out, and they both have an 11, so that would divide out. And once you divide that out, all that's left in the numerator is 5, and in the denominator, 2 times 2, which would be 4. So 5/4 would be your answer. The next type of thing you have to do with fractions is to be able to multiply them. And the rule when multiplying fractions is you multiply straight across. So you multiply the numerator by the numerator, denominator by denominator, and then we reduce if we can. So in this first example, 3 times 10 is 30, and 8 times 9 is 72. And then we're going to reduce just like we did above. So with 30, I can think of that as 3 times 10, but then 10 can be broken down into 2 times 5. So I could write this as 3 times 2 times 5. And then I'm going to do the same thing with 72. So for 72, I could do 8 times 9. And then 8 can be broken down into 2 times 4. And 9 can be broken down into 3 times 3. And then 4 can again be broken down into 2 times 2. So we end up with 2 times 2 times 2 times 3 times 3. And we're looking for common factors. So we have a 2 in the numerator and denominator, and we have a 3 in the numerator and denominator. So we have 5 left in the numerator, and then 2 times 2 times 3. So that'd be 2 times 2 is 4 times 3 is 12. So 5/12 would be my answer. And then the last one of these is 12 times 9 would be 108, and 7 times 8 would be 56. And once again, we're going to break these down. I'll go down below here so you can see this. So 108, anything even can be divided by 2. So if you divide 108 by 2, it's 2 times 54. 54 would be 6 times 9. And then we just keep carrying along the 2 because we can't break it down further. The 6 could be 2 times 3, and the 9 would be 3 times 3. So I would have 2 times 2 times 3 times 3 times 3. And I'll do the same thing with 56. 56 could be broken down into 2 times 28. And then 28 would be 4 times 7. And then 4 would be 2 times 2. And you'll notice the 2 and the 7 I just carry along, and then I broke down the 4 into 2 times 2. So I would end up with 2 times 2 times 2 times 7. So we have a common factor of 2, another common factor of 2, and that's it. So I would multiply 3 times 3 times 3 is 9, and 2 times 7 is 14. And I would end up with, 3 times 3 times 3 is 27. I left a 3 off. So 3 times 3 times 3 is 27, and 2 times 7 is 14. So I would end up with 27 over 14. And that's how you multiply fractions. Okay, the next thing we're going to look at is dividing fractions. And dividing fractions actually becomes multiplying fractions, because the rule for dividing is that you rewrite it as the first fraction multiplied by the reciprocal of the second fraction. And reciprocal simply means that you flip it. So I'm going to write down the first fraction, change division to multiplication, and I'm going to do the reciprocal of 3 over 20, which would be 20 over 3. And then we just follow the same rule as we did for multiplying earlier. So we multiply straight across. 9 times 20 is 180. 5 times 3 is 15. And one of the things you could always do when you're dividing fractions is, or when you have 180 divided by 15 or any other fraction, you can always check and see, will it divide evenly before you try reducing it? And this one actually does. 180 divided by 15 is 12. So you don't have to go through the steps of reducing because it actually just divides evenly. Okay, one more of these. When you're dividing, you keep the first fraction, you change division to multiplication, and you switch or flip the second fraction to get the reciprocal. Now, if I were to multiply these as is, these would be very large numbers. And so one of the things you might do is you might keep the 7, and instead of multiplying 7 times 99, keep the 7 times and then break down the 99, because that's what we're going to do to reduce anyway. After we multiply, we're going to turn around and break it down. So it might be easier to go ahead and multiply and make that 9 times 11. And then we're going to have the 72 times the 77. Go ahead and break the 72 down into something you know multiplies to 72. And there's other things, but 8 times 9 comes to mind immediately. And then the 77 could be 7 times 11. So rather than multiplying them and then getting these large numbers that you have to break down, go ahead and just keep the multiplication and break down the individual numbers. And that would actually work on these previous ones that we did as well. So for example, I'm just going to pick this one here, the 3 over 8 times 10 over 9. I could have left that as 3 times and then rewritten 10 as 2 times 5. I could have rewritten 8 as 4 times 2, and 9 is 3 times 3. And then we could have reduced there and ended up with 5 over 12. So that's actually an option, is instead of multiplying and then reducing or breaking them down into factors, go ahead and break them down into factors at the beginning. So when we do this, we see that the 9s are common factors, and we have a 7 of common factor, and we have an 11 that's a common factor. Now, this is the first example we've seen this where everything in the numerator divides out. That doesn't mean that it's gone and that it's 0. That actually means that we divided, and with any of these, 7 divided by 7, 9 divided by 9, 11 divided by 11, all of those actually equal 1. So when everything divides out, there's still a 1 there. So this would end up being 1 over 8 for our final answer. Okay, the next thing we're going to look at is adding and subtracting fractions. And adding and subtracting fractions requires you to have the same denominator. So in order to get the same denominator, we have to think of in terms of what two numbers will go into. Instead of what number will go into something, we're thinking of what these numbers will go into. So I have 1 over 6 plus 2 over 3. So I'm looking at the 3 and the 6. And I know that 3 and 6 will both go into 6. So the 1 over 6 can stay, but I have to turn the 3 into a 6. And in order to do that, I multiply by 2. But the rule with fractions is, in order to balance it and keep it the same value, whatever you do to the denominator, we have to do the same to the numerator. So if I'm going to multiply 3 by 2 to get 6, I'm going to have to multiply 2 by 2 as well. And what I'm actually multiplying by here is 1, because 2 over 2 is 1. So I will rewrite this as 1 over 6, and then that would become 4 over 6. Once you've done that, you keep the denominator and you add the numerators. So 1 plus 4 would be 5, and then we would keep the 6. So our final answer would be 5/6. Okay, now one with subtraction, we're doing the same thing. We're looking at 9 and 6. So what will 9 and 6 both go into? We know that 9 and 6 will both go into 18. If you're not sure, if you can't see it right off, what you would do is you write down the multiples of 9. So we know 9, 18, 27, 36, and so forth. And then you do the same thing with 6. 6, 12, 18, 24. And you do that until you see a common factor or a common multiple. So the common multiple would be 18. So we know that 9 and 6 both go into 18. So I'm going to rewrite both of these and change them into 18. So I'm going to write down my fractions that I was given, but I'm going to leave myself room to change these to 18. To change 9 to 18, I multiply by 2. So I also have to do that in the numerator. To change 6 into 18, I have to multiply by 3. So I also do that to the numerator. So when I do the multiplication, that would be 4 over 18 minus 15 over 18. We write down the common denominator, and then 4 minus 15. So we learned earlier, you can think of that as 4 plus negative 15. The signs are different, so I subtract and keep the sign of the larger number. So that would be negative 11 over 18. And then the last thing we're going to look at is, what do you do when you have fractions with decimals inside of them? And we're still going to follow the same rules for multiplication, division, addition, and subtraction. But instead of reducing the fractions like we did earlier, we usually will just use a calculator and divide and give our answer in decimal form. Because if the problem has decimals in it to begin with, they will usually accept your final answer as a decimal. So these will be a little bit easier because we won't have to reduce at the end. So the first one is division, and we want to divide, so we're going to follow our rules from earlier. So we write down the first one, we keep the first the same, we change division to multiplication, and then we multiply by the reciprocal of the second fraction. So we flip the second one. And then for multiplication, we multiply straight across. Use your calculator to multiply 6.3 times 45. So we get 683.5. And then 9 times 1 is 9. And then use your calculator to divide, and that would equal 31.5. And on these, I think on the examples I looked at, it said 2 decimal places. So it wouldn't affect this one because we only have 1 to begin with. But if it didn't come out to 1 decimal place, you would round to 2. Okay, the next one, 19 over 16 minus 3.1 over 24. We have to find something that, because it's addition or subtraction, we have to have a common denominator. So we need something that 16 and 24 will both go into. So I've got to find something to multiply these to make these the same number. So again, if you don't know off the top of your head, you can use your calculator and do 16 times 2, which is 32, 16 times 3, which is 48, 16 times 4, which is 64, and you can just keep going. 24, and then 24 times 2 is 48. And as soon as you see that common multiple, you can stop. So these will both go into 48. So this was 16 times 3. So I have to multiply by 3 up here. This was 24 times 2. So I have to multiply by 2 up here. And this would give me 57 over 48 minus 6.2 over 48. Common denominator would be 48, and then 57 minus 6.2 would be 50.8. To get our final answer, we'll just use our calculator to divide, and when we divide that, this one comes out to 1.0583. We need 2 decimal places, so we're looking at the 5. 8 is 5 or greater, so that means the 5 is going to go up to a 6. So we would end up with 1.06.